Hi, everyone. Thank you again for joining us for day 2. We're going to wait a little bit as everyone streams in, and then we'll get started with the second session. And tell us where you're coming from in the chat.
Seems like we're kind of steadying out at 24. Maybe wait like 30 more seconds and see what happens.
We have people from everywhere. We have someone from Texas who just moved from Texas. Someone from China, welcome. It's early there. So yeah, definitely thanks for joining. Massachusetts, we both went to school there. If anyone is coming from San Francisco, we hope that things are better there, that it's less scary, less apocalyptic, that you're all staying safe.
All right, kind of seems like we've been at 27 for a while. So I think we're gonna get started. And I'll start with some quick intros and then we'll jump right into the content. So hi everyone, thank you for joining us tonight for this SAT prep stream. And a special thanks to those of you who are joining us for the second night in a row. So if you were here yesterday, you know that my name is Grace Kosia and I'm the Chief Academic Officer of Almost Fun, and I'm joined by our CEO, Lisa Wong. Fun fact, we actually went to college together at Harvard, but we didn't actually meet in person or know each other until we started working together. So about our organization, Almost Fun is focused on helping students learn in a more relatable, familiar way. And we're excited to be partnering with Fiveable to bring you some streams about the SAT. All right, so tonight we're gonna be focusing on the more advanced math topics that show up on the SAT. Yesterday we focused on the core concepts. Today we're getting into the more involved problems. The stream is gonna be about 90 minutes long, so stay as long as you can and be sure to check out our resources on our website. So I think I have the ability to share my screen, I should. And I'm gonna show you guys a little bit as to what that website looks like. So a lot of you guys are gonna be seeing, we're gonna be using a lot of resources from the Almost Fun website. The URL is simply almostfun.org, pretty simple. And from there you can access lessons that break down core concepts into sizable chunks. And then we also have some guides that might be helpful for you, especially for the SAT. And then if you click on Practice Now, you'll be able to access more of the questions that we'll be going over today. Perfect. Let me stop my share. All righty. So today we'll be focusing on the advanced topics. And before I jump into the advanced topics, there's actually one more thing I need to show you guys. I'm a little nervous. I'm excited to meet all of you guys, although it's virtual, but we're doing the best we can. Hashtag COVID. Lots of tech going on here. All right, so I'm gonna share my screen again, and we're gonna jump into one of our guides. Alrighty, so when you jump into our guide section and you click about the SAT, it'll break down the main components of the SAT, and you'll see how much time you have per section, per question on the big day. So for the math, which we'll be focusing on today, there's 2 sections, no calculator and calculator. And for the no calculator portion, you have 20 questions, 25 minutes, which means only 75 seconds per question. Sounds a little crazy, but it's doable as long as you get enough practice in there. For the calculator section, you have 38 questions, 55 minutes, and a little bit more time per question, coming in at 87 seconds. So I know that you guys may have more questions involving like general SAT, the format, what score to go for, should you submit or should you not. You're more than welcome to submit those questions using the Q&A feature, but please note that we're gonna wait till the end to answer some of those questions. As we go through the lessons though, feel free to ask questions about the content, and then Lisa will do her best to answer them as they come in. And then if there's like big questions that are common around students, we'll try to answer that live. Perfect. So many screens. Switch back to the other one. So I'm going to be using our SAT math guide. And so if you're actually looking, with us on the website, I'm going at guide and I'm clicking down to 27 critical SAT math concepts to remember. There will be opportunities for you guys to get some time to try out a problem before I go over the answer. So if you are looking along, try not to scroll too far down, otherwise you're gonna miss the opportunity to see if you actually get the stuff. All right, so the first thing we're gonna talk about is sampling, scrolling all the way down into section 2. Love scrolling. Also, background, I used to teach high school, so if I talk a little differently than Lisa, it might be because I've been stuck with high school kids for a long time. So that's me. All right, so with sampling, that's going to show up on the SAT. And the big thing you want to know about sampling is what is a random sample and how do we use it? So a random sample is a small group within a larger group of people or items that is representative of that larger group. So if we're talking about a high school, we're thinking a random selection of 10 students from that high school, not just seniors, not just juniors, not just girls, not just boys, not just the hockey people. We're talking about a random sample of from all the students in the school. And once we have a true random sample, we can use that to make estimations about the larger group. So if you take a look, I kind of scrolled down too far. If you take a look at this problem right here, we have in a random sample of 200 cars of a particular model, 3 have a manufacturing defect. At this rate, how many of the 10,000 cars of the same model will have a manufacturing defect? So in true teacher fashion, I'm gonna give you guys a minute. Hopefully you guys didn't already see the answer. But I'm gonna give you guys a minute to try to solve this problem. About 20 seconds left. No pressure. All right, I kind of lost track of time there, so you got a little extra time. So let's see if you guys got it correctly. So here we're actually using another math concept, which is ratios and proportions. And the type of ratio that we're going to be using is a part to whole, where we have our sample of 200 cars. So that's the whole, which is the total of the sample. And then out of that sample, we have three cars that have a defect. So from our sample group, we have 3 over 200. And we want to make an estimate about how many of the cars from the larger group, 10,000, are also going to have defects. So when we set up our proportion and we solve it like a regular equation by first isolating the x, multiplying both sides by 10,000, dividing, we get that the number of cars that should have defects in the larger group of 10,000 cars is 150. So that's one example of how we use random samples. They're usually just used to make estimations about what's going to happen in a larger situation using a sample from that same group. But because they're just estimates, we also want to include a margin of error. So it's important that you guys also know what a margin of error is. The good news is that you don't have to know how to calculate it. You just have to know what it is and how to use it. So looking at this, we can see that a margin of error is an estimate of how off your sample is. So if it's really big, then your estimate is not the best, but it's workable. And if it's smaller, then that's great. Like we're close, like we have like a good idea of to where things are gonna fall. So let's take a look at the example that's here. We have, if we let's say out of the sample of 10 of your classmates, 30% think Kanye's only running for president to boost album sales. Oh, Kanye. Then we look at the total population of the school. We estimate that the margin of error is about 5%. That means that within the total population of your school, the percent that think Kanye is only running to boost sales is somewhere between 25% and 35%. So notice that all we had to do was add 5 to our estimate, and then also subtract 5 from the estimate. So we have our range of 25% to 35%. All right, so let's see how well you guys understood that. Let's look at the next example problem. Try not to scroll down too far. All righty, I'm gonna try to read it slowly to give you guys a little head start to the question. A researcher surveyed a random sample of students from a large university about how often they see movies. Using the sample data, the researcher estimated that 23% of the students in the population saw a movie at least once per month. The margin of error for this estimation is 4%. Which of the following is the most appropriate conclusion about all students at the university based on the given estimate and margin of error? All right, I'm gonna let you read the choices and decide which one you think is correct. All right, we're down to the last 3 seconds. Moment of truth. Okay, so in true SAT fashion, all of these questions seem like they could be correct. Like nothing seems wild out of place. Like it seems reasonable. Keyword reasonable. And so we have to like really think about which question is actually correctly using the margin of error, or the correct definition of margin of error. So I'm gonna go ahead and start with I'm gonna do a spoiler and tell you what the correct answer is and explain why the other ones are incorrect. So the correct answer is D. So if you got that correct, congratulations. Let me make sure I didn't, yeah. So the correct answer is D. And well, let's look at A, B, and C and figure out why those are incorrect. So A says it is unlikely that less than 23% of the students see a movie at least once per month. Well, we don't know that it's unlikely. Technically, if we subtract 4% from our estimated 23%, that's still within the range. So we can't make that blanket statement. Not okay. B says at least 23%, but no more than 25%. So it's the same thing, similar to why A was wrong. It's the same thing with B, right? We could go up to, it could be a possibility that we have up to 27%. It's likely. And then for C, careful with this one. The margin of error doesn't tell you how sure you are about something or how certain you are about a prediction. It only tells you what prediction or what estimate is reasonable. So I hope you guys can recognize the difference between those two. It doesn't tell you how certain you are, it just tells you what's a reasonable range. All right, take a little breather right there, take a little breath. And remember, if you have any questions, make sure to fill up that Q&A. It's really hard to keep track of the questions in chat, so make sure you're using that Q&A feature. All right, and while you guys play around with that, I'm gonna pull up our first almost fun question. Okay. All right, Lisa, can you give me a thumbs up if you're seeing the almost fun questions? Perfect. Got 2 screens going here.
No,
all right, so
we're still on the guide. Sorry about that.
Oh, okay. Let's try that again. Let me just do stop share, make a new share, and I believe it is this one. How about now?
Yes, you're good.
Okay. Whew. Okay. So I'm gonna give you guys some time because yesterday a lot of people wanted time to work through a problem before we just spit out the answer. So go ahead, and I might have to zoom out a little bit if I can figure it out. Well, you should be able to see all of the 4 answer choices. So go ahead and give this question a try, and we'll see how we do. So 10 more seconds. I may have shaved off a few seconds just because we're running low on time, or there's a lot to cover. All righty, let's see how we did on this one. Ooh, thank you, Apple. All right, so let's say that I'm gonna purposely just pretend like I don't know the answer because that happens. And the cool thing about our app is that even if you don't know the answer, we don't leave you hanging. We're gonna walk you through. And I keep saying app, but this is also available on the website. So let's say I don't know what's going on. The first thing we want to look at is what are we dealing with? So in this problem, Tanya surveyed a small group of her classmates and found that 93% of them have seen at least one Tyler Perry movie. But without surveying every single student at her school, she can't know for sure that all 93% of them have seen a TV movie. So to recap, is 93% the true percentage of all her classmates, or is it just like an idea, an estimate that we're making? The answer is no. So right now the margin of error tells us how far this small group percentage is from the whole school percentage. Basically, the whole school percentage is somewhere in the range from 93% minus the margin of error, the minimum end, and the high end is going to be 93% plus the margin of error. So when we do that math, careful with it, don't just do one, not the other. Let's subtract the 2% from 93 and add it. So the correct answer is going to be the top one. Okay, so once you walk through that, you can go back up, and based on what you answered correctly, you can pick the correct answer. So kind of like what we just did right here, we can see that the correct answer is going to be C, right? We know the range. We don't know, we're not talking about certainty, so the correct answer is C. And you get a little fireworks. All right, so now we're gonna jump into our next segment. And now that hopefully you're getting a little bit more comfortable, I'm definitely getting a little bit comfortable. We're gonna try to speed it up just a little bit to make sure that we cover as much as we can during today's session. All right. And we're gonna go back to the guide. Perfect. All right, so our next thing that we're gonna talk about is functions. So I'm actually gonna scroll back upwards, and hopefully you guys didn't see any of these answers. So for functions, they're fun. People get a little bit intimidated by them, but they are fun. I love functions. So for functions, you'll need to know how to plug something into a function to get an output, how to graph a function, how to read the function, how to read the graph of a function. If you're not sure what a function is, which is a word that I'm going to keep saying, check out our functions lesson. It's pretty fun, has a little showing machine. You'll like it. So whether it's just plugging in input values to get an output value, the answer in this case is going to be 1. I'm not giving you guys time for this one. And then if you look at the second graph, you have a function that also has a second question. So even though I'm not giving you guys time to go through these questions, I'm actually going to explain it. I got a little excited. So whenever you guys see f of x, and hopefully this is review, but if this is new, that's okay. Whenever you guys see f of x, it's simply it's like you can look at it as y, or what is this equation going to be equal to when x is equal to something. So based on this question, we have what is the value of the function when x is equal to -1. So what you're going to do is you're going to plug in -1 to everywhere you see x, which is only one case in here. When you do all that math, the answer is there. It's no secret. Your answer here is 4. Oh, sorry, your answer here is 1. I was looking at the wrong one. All right, now when we're looking at the graph, similar situation, just looks a little different. Don't freak out when you guys see graphs. Graphs are your friends. So here it's saying that the graph of y equals f of x. So this is the function that represents this curve. It's shown in the xy plane. What is the value of f of 0. So essentially, we're being asked, what is y equal to when x is equal to 0? So I hope you guys are seeing that pattern. F of something is just saying, what is this equation equal to when x is equal to that something? So if you were to look at where we have 0, very center, we set the y is 4. So again, this is what I'm saying, graphs are your friends. You see how much easier that was? We didn't have to do any math. We just had to look at the point, find it, and bam, we have our answer. All right, so let's do some almost fun practice questions. I really want to get faster at switching screens, but I'm not there yet. That's okay. All right, back to screen 2. Y'all see Chance the Rapper dancing? Yes. All right, I'm getting better at this. All righty, so let's do our first problem. Y'all see an orange screen with a question? Awesome. All right, so go ahead and try out this problem. You have to read it very carefully. I may have to scroll down. Nope, I'm good. And I'll give you guys 1 minute to work through it. $15 more seconds. All right. Alrighty, so let's go ahead and read through this question first. How many seconds will it take for her to fill the entire balloon? So I want to emphasize this, and I'll probably say it again once or twice more, is when you are solving an SAT question problem, always really important to make sure you know what you are solving for. And you'll see why in a couple of questions from in a different section. So we know we're solving for time, how many seconds. So we want to make sure we know which variable represents time. It's t in this case. Awesome. And we're trying to figure out when the entire balloon is going to be filled. So in order to understand this equation, again, where SAT is really testing your ability to understand an equation, not just see numbers and letters, we have to make sure we understand what this equation is telling us. So volume at a given time. So how much volume do we have, or how much space do we have in the balloon whenever t is equal to something? And this is the equation we can use to solve for that volume. So if we're looking, let me not jump ahead. I don't know, help me. Okay, so once the balloon is totally filled, what should v of t equal? I kind of jumped down because I gave you all the preface. Is it going to be 0? Is it going to be 10? Filled, no space, so it's 0. Awesome. So when the balloon is totally filled, we know that v of t is going to be equal to 0. V of t is the same thing as f of x. You're going to see various different formats of it, but just think it's the same thing as y, or like what is something equal to when a certain variable is equal to something else. So don't get tripped up by all the lovely letters that show up in math. It's the same format, same concept. So since we want to know the time t that this is true for, we'll set the equation equal to 0 and solve for t, which is super duper easy. And when we do that, we know that time can't be negative. So it should be 18.9, okay? So now that we have the correct answer, go back up, click it, get your sparkles, life is good. All right, I believe I had a second question I wanted you guys to do, but I don't know if we're gonna have time. Let's do it. Why not? Nope, actually, no, we're not gonna do it. All right, so let's, I'm gonna jump back to the guide because even though for this one, there isn't an SAT question for it, you do wanna know how to do this. And by SAT question, I mean like on our app, but you definitely wanna know how to do this concept. So let me go back to here. So much jumping around. All right, so function operations. So this one we're not going to spend too much time on, but you do need to know how to do them. So beyond just knowing how to plug and chug and see what is y equal to when I plug in a certain value for x, you have to know how to work with multiple functions. Ooh. So that can be like adding functions, dividing them, multiplying them, subtracting them, you name it. You have to be able to do that. And then sometimes, in some cases like this one, you'd have to be able to simplify it. So in this particular problem, I'm going to jump right into it. No time for you guys on this one. We are being asked for what is f of x, which of the following expressions is equivalent to f of x divided by g of x. So we have our two equations listed up there. All we're going to do first is substitute the right side of both of those equations for their f of x and g of x, respectively. So if you look down, hopefully you guys can see what I'm seeing. We have x cubed minus 9x divided by x squared minus 2x minus 3. And then each step along the way, we're simplifying. The first round, we pulled out the x. And you want to keep an eye out for, because sometimes like you're not going to have to fully simplify the problem or your work to get to the correct answer. So you kind of want to take a look at the answer choices, see how simplified they are before you go head in and dive right into simplifying the whole thing. So in this scenario, we did have to go all the way to that final line to get our correct answer of D. But I just want to really point out to you guys that for saving some time, always check what the answer choices look like. If they're simplified, then that gives you a hint that you're going to have to definitely simplify all the way. But if there's some areas where they're like you're seeing x squared or like something like in the second line of the work, then it might give you a hint that you don't have to go all the way in order to get to the correct answer. All right, so now we're going to go. Oh, sorry, go ahead, Lisa.
We had a couple of questions in the Q&A that I'm just going to go over and kind of recap the last couple of concepts that we've done. So we had a couple questions about, like, do we need to know how to calculate the margin of error back when we were doing sampling? You never need to know how to calculate it. You just need to know how to use it. And then for that last question that Grace was doing around filling the balloon, you can definitely distribute that out and get to the answer, but it just takes a little bit more time. And our goal with all of these is to answer the questions as quickly as we can, because you don't get a lot of time for these math questions. You get like a little bit more than a minute, like Grace said, and you want to save as much time as you need for the questions that are a little bit more challenging. And then a couple more questions. So does the SAT require rationalization? Yes, only in that sometimes your answer, they don't usually have irrational answers as choices. And so you'll need to rationalize like the denominator or something to make sure that your answer you see as a choice. And then for this specific question, someone asked if we need to know if the x is greater than 3 part of the question is important. And that's a really great question. In all of our experience, looking through all the practice tests, doing all these questions, we have never once seen it be important, and it's always a little bit of a distraction. Maybe the SAT will surprise us one day and give us a question where it is relevant, but our recommendation is just ignore it, solve it, simplify it. If you're getting stuck somewhere, then maybe that piece of information will be helpful, but in general, we think that you can just ignore it. And then last question before I let Grace keep going. And I think we have a lot of time, so no need to rush through some stuff. We're good on time. But there's a question about multiplying or dividing fractions that you haven't learned that yet. There's not really going to be that many questions on this topic. So if you focus on mastering some of the concepts that we went over yesterday and you've got those, then it might be worth, studying this in case you get like 1 or 2 questions on it. But I wouldn't spend all of my time trying to learn this whole new concept. I would only do it if like you feel really good about everything else. And yes, these sessions will be recorded and sent to you. Okay, back to Grace.
Awesome, thank you, Lisa. All right, so I'm glad that we're doing well on time. It's hard to see where it all is whenever you have 5 screens looking at you. So, and I'm glad that we have that because the next topic is actually going to be trigonometry, and there's a little bit more to unpack in that one. So we're going to scroll down in our lesson to trigonometry. All right. So In addition to what's already listed here, there's a couple other things that you might want to know that could be handy in shaving some time whenever you're answering questions that relate to trig. So for starters, you want to know how to find cosine, sine, and tangent of an angle given either sides of a triangle. And then you also, I'm going to go back to that in just a second, don't worry. But then another one that students often tend to overlook whenever they're studying for the SAT is this last one that I've highlighted. Cosine of x is equal to the sine of 90 minus x. We're going to walk through an example problem that actually like puts that into application to where it's not just an equation, but that is something that you're going to want to remember, because in the case that you had a question that asked you, what is cosine of x minus sine of 90 minus x equal to? And granted, x is going to be a different variable, of course, because it's the SAT. You should already know the answer. It's going to be 0 because you have the same value value minus the same value. That's going to be equal to 0. 5 minus 5 is 0. Cosine of x minus sine of 90 minus x is equal to 0. That was my parentheses. All right, so going back to those first three, whenever you're given a triangle and you're trying to figure out how do I find cosine, how do I find sine, or how do I find tangent, you may or may not have heard of this before. This is not something I've created. I wish I was this smart. It's called SOHCAHTOA. So I'm actually going to draw it out, and you guys should be able to see it on the screen. You're all seeing my lovely handwriting? No? So sad. Okay. So you can't see it. Okay, there's a lag. That's okay. It's better than nothing. SOHCAHTOA. It helps if you say it out loud, even if you're in your room by yourself. No one's going to judge you. It's okay. SOHCAHTOA. So that is, I think the correct word is acronym that I use to help me remember to this day, I still use this to help me remember the equations for sine, cosine, and tangent. So for sine, we have, I'm going to refer back to the bullet point right here. We have that sine is going to be equal to the opposite side from the angle divided by the hypotenuse. So it helps if I also draw a picture to reference that. Don't judge my lack of straight lines. This is harder than it looks. Can you guys still see everything? Perfect. And by you guys, I'm just like looking at Lisa. Thank you, Lisa. All right, so let's say that we are given this angle. All right, I'm gonna call it X, because why not? So then the side, if I want to find sine of the angle X, the side that's opposite, this is considered opposite. Sometimes that can get a little confusing. And the side that's next to it, adjacent, is right here. So we call the adjacent side the side of the triangle that's literally touching the angle, but don't get that confused with the hypotenuse. The hypotenuse is the special one, the one that likes to be by itself, nice and diagonal. It's chilling. So the hypotenuse is always doing its own thing. Or you can look at it as the side that is across the right angle. Okay. All right. So that being said, if I wanted to find sine of x, I have, getting a little harder as I go down the page. Sine of x would be equal to the opposite over the adjacent. Imagine that those are numbers and my handwriting is not as bad. I might have to stop there because I'm getting a little too low. Okay, yeah, we're not gonna go further than that. But hopefully you guys can kind of see like the pattern. So I'm gonna say it out loud. And then with cosine, you have cosine of x would be equal to whatever value you have on the adjacent side divided by the hypotenuse. And then for tangent, it's actually going to be, we're forgetting about the hypotenuse, and it's actually going to be the opposite side over the adjacent. Okay, and you want to make sure that you're paying attention to whether you're using degrees or radians, because if it's in the calculator section especially. All right, and tangent is a little special in the fact that you can also find tangent by dividing the sine of the angle by the cosine of the angle. Okay, so there's two ways that you can find tangent depending on what information you have. So don't get boggled if you can't find it one way. There's always a second way. You want to make sure you have that down. All right, so there's a little bit more when it comes to trigonometry. So the word special right triangles should just like be in the back of your mind and hopefully now it's in the front of your mind, because there are special right triangles that you're going to need to know. And you don't have to worry about memorizing them because they are on the reference sheet on the math, on the front of the math section of the SAT. But it helps if you're already kind of familiar with which ones they are. That way, once you recognize one, you can just quickly, if you need to, go back to the sheet and just confirm that you're using the correct sequence. So the three special right triangles, we have the 3, 4, 5 triangle, which just means that if the side is 3, 4, then the hypotenuse is going to be 5. And the same is true for the multiples. So if we had 6 instead, let me see if this eraser actually works. Nope, that's not working. All right, I'm gonna draw you a triangle. So if we had 6 instead here, everything, what we're talking about multiples of 2 by 2. So we have 8 would be here and 10 would be the hypotenuse. All right, so it really helps you with saving for the non-calculator part, even the calculator part. If you're able to recognize when you have a 3, 4, 5 triangle, it could definitely save you some time. The other triangle is the 30, 60, 90 triangle. And then we have the 45, 49, 90 triangle. So the 45, 49, 45, 90 is like the isosceles triangle, where both the two sides are equal, and then you have the hypotenuse. And then the 30, 60, 90 triangles where they're different sides clearly. Okay, so hopefully, like I kind of hinted it when I was talking about the 30, 60, 90 triangle versus the 45, 45, 90 triangle, where you can kind of see that there's a relationship between the angle and the length of the side that is opposite from it. So this is where it's not on the screen, but I am going to talk a little bit about it. This is where we kind of get into the notion of congruency and similar triangles. So you're going to hear those words on the SAT, and it's important that you know the difference between those two. Congruent means equal. So like the two triangles are the same, life is good, same angles, same sides. So if we're looking at this first problem here, these two triangles are not congruent. But we can say that they're similar. Similar means that their angles are equivalent. So if I'm looking at this angle here, it's a right triangle, it's going to be the same angle that's next to the D. The angle for F, that's an eraser. The angle for F, still an eraser, is going to be the same angle for C on the smaller triangle. The angle for E is going to be the same angle for B on the smaller right triangle. So again, re-emphasizing, because it's super important that you remember and that you don't get these confused. Similar means same angles, different sides, so different sizes. Congruent means equal angles, equal sides, so they're identical. All right, so that being said, and now that you've kind of already had time to look at the question, I'm going to scroll down. Let me stop drawing and let you guys take a whack at this one. Take a try at it. Gave you some major hints. All right, take about 30 more seconds. Final 5 seconds. Oh, righty. Okay, and I accidentally scrolled way down by accident and lost my spot. All right, here we go. So because we know that similar triangles have the same angles, we know that cosine of E, because remember we're talking about like an angle, the cosine of angle E here, if you guys can see my my mouse, is going to be equivalent to the cosine of B. So we have all of the information for that first triangle, and which means that we have enough information to find what cosine of B is equal to. Thinking about SOHCAHTOA, cosine is that ka. So cosine of angle B is going to be equal to the side that's adjacent to it divided by the hypotenuse. So we have 12 over 13, and the correct answer choice is E. Awesome. So again, I know I keep saying this, but it's because I really want you guys to remember this on the day of the test. Whenever you have a similar or congruent angle triangles, that means that the angles inside them are equivalent. So the corresponding angles from one triangle to the other are going to have the same value. So if you have enough information in one triangle to find the value of an angle, you also know the value of that same angle or the corresponding angle in the larger or smaller triangle. But just remember that congruent and similar are not the same thing. All right, so in this next problem, I want you guys to remember what I said about cosine of X being equal to sine of 90 minus X, okay? And this problem, based on that, you should be able to quickly figure out what is the correct answer for this next sample problem.
Grace, can you scroll down a little bit?
Yeah, it kind of gives the answer, but are they not seeing the bottom of the triangle?
Sorry, the
Oh,
bottom
okay.
of the question, I think, just a little.
Oh, okay. Oh, if they can you see the answer now though?
Yeah, it's okay.
It's okay. All right. Well, since the answer,
I was just saying, some of these questions, there are no choices, so they're just fill in the blank, but yeah.
Yeah. So in this scenario, I also, something I didn't ensure that we're on the same page of is whenever you're given an angle in the notation given below where it's like angle RSW, the quickest way to figure out which angle it's referencing is that S value. So like the middle, oops, sorry. The middle letter gives you like which point you're kind of going to be focusing on. But what's a little bit different here is that we're not talking about angle RST, which would be just that right triangle. They're not going to make it that easy. It's SAT. So we have to look at what is actually going on in this problem. So in the right triangle, RC above, point W, which they didn't show us, is somewhere along this line RT, okay? And we want to figure out what is the value of cosine of RSW. So let's just pretend for funsies, if I can annotate and just make a little point in red. Let's just pretend that point W is here, okay? W. So they're talking about the angle RSW is this angle right here. And the angle WST, or yes, WST is this one right here. I'm only going to depth about that so that you guys, I want to make sure we understand the notation. All that I'm doing here is not fully necessary because we can see that WST and RST, this right here, this angle is going to be 90 degrees minus that other angle, the X, right? So 90 degrees minus RSW, or if we look back at this equation, that's our X. So in this case, we have two equivalent angles or two equivalent values that we're subtracting from one another, and same thing minus the same thing is equal to 0. Right? And if that's not quite making sense, feel free to ask follow-up questions, because I did kind of like get a little choppy with my explanation there. But hopefully, and it's really hard to draw with this pen, but hopefully you guys are seeing what I mean by, one, how they notate angles, and then two, this really helpful principle to remember about cosine of x is equal to the sine of 90 minus x, because they're the same thing.
Okay, so we had two questions. So one, will we need to, for this specific question, what are the chances the answer will not be 0? Yeah, I think that that's a good point, that like, if you maybe don't remember that identity and you're not super sure how to do this question and it's a fill in the blank, there's like a pretty good chance that answer is going to be 0 or like something really simple. But they might have also asked you like, what is the value of cosine RSW divided by sine of WST? In which the case the answer would be 1, not 0. So like, they're really trying to test that you know that identity, but it might not be like through the subtraction, it might be through division. And then I see that someone is still confused about how we got 0 here. Okay, so we know the identity cosine of x equals sine of 90 minus x. I'm just gonna run through this one more time. And if we look, we can see that on Grace's sketch here, RST, that's a 90-degree angle. So cosine of RSW, that RSW is equal to 90 minus WST. So those two angles equal 90, which means that cosine of RSW is equal to sine of 90 minus RSW, which is the same as sine of WST. So that means that those two are equal. So if we subtract one from the other, our answer is 0. And then one more question, will we need to memorize the unit circle for the SAT? And the answer is maybe. It's another one of those concepts similar to trig identities that someone else asked, where you're pretty unlikely to see a question that relies on one of those concepts, but like nothing is totally out of bounds on the SAT other than like calculus. And so there's still a chance that you would see it. I would say like, if you feel really confident in all of this basic stuff we're going through here, then like that's a good thing to study next, just on the small chance that you do get a question like that. Follow up, what is the highest level of math we will need? Like trig is the upper bound. That's the upper bound of what you need to know. Basic algebra, like algebra 1, algebra 2, geometry. Grace is gonna go over a couple more advanced topics, but trig is probably like the most advanced thing. Back to you.
Awesome, thank you so much, Lisa. All right, so now we're gonna jump into some of our almost fun questions that involve trig, and you'll get some additional time to practice. So this is the longest one that this is the one that we're gonna spend the longest time on, just because there's just so many different types of questions that can involve trig. I really wanna make sure that we're going through as many examples as possible within our time constraint for today. So clear all drawings and screen two. Alrighty. So go ahead and read that question. Do your best shot at it, remembering some of those big pointers about those definitions that we discussed at the beginning and identities and principles. Alrighty. So we've got a major Dorito fan, and hopefully, I love Doritos. Personal favorite is the Cool Ranch. I know people feel certain types of way about that, but that's my favorite flavor, or spicy nacho. But that's the math. And this one's a cool one because we'll also get to review just some things to remember whenever you're filling in the answer sheet for a free response question. Alrighty, so the big thing to know is that we have a similar triangle. Okay, so I'm just like pointing out some keywords that you definitely want to take note of whenever you're reading through these questions and and it involves trig. So similar, again, saying it one more time, is that the two triangles have the same set of angles, but their sizes are different. They're proportional, but they're different. All right, so let's go through and solve this problem. With trig, if you're not given a picture, you might want to draw a picture. I know we're talking about saving time, but imagine trying to figure out what all of this means in your head. If you can draw a picture, and like that's gonna, like you want to think about what is gonna help me get to the answer quickest, and you know how your brain works the best. So if you are a visual person, draw that picture. So in this case, we drew both of these, drew like representations of both Dorito chips. So we have the big door and we have Ito on the side. So again, they're similar triangles. So they have equivalent angles, but very, very different sizes for their sides. All right. So, sorry, I missed the question here. All right, so we also know that triangle Ito is similar to triangle door. I'm just going to say the word like that, where points ITO correspond to points DOR. It's really important that you know which points correspond to each so that you know which angles are equal. We'll draw a smaller triangle where I is in the same spot as D, T is in the same spot as O, and O is in the same spot as R, as seen here below. And we can do this because the triangles are similar, not congruent. I love every time I get the opportunity to really emphasize the difference, and I feel like y'all are going to nail that on the SAT. All right, so since the triangles are similar, we want to see if they're, and we're solving for, we want to know what the sign of I is. We want to figure out if maybe we have enough information to find the sign of the angle that it's equal to on the other triangle, right? So if we don't have enough information on the triangle that we're focusing in on, you're probably going to have enough information on the triangle to which it's similar. So the cool thing about similar triangles is that sine of I over here is going to be equal to sine of D because they are the same angle, similar triangles. And so we can figure out, we have enough information to figure out sine of D. Sine is opposite over hypotenuse. It's the so and SOHCAHTOA. I believe that repetition is powerful, so I'm going to repeat a lot of things until you guys are so tired of hearing it, but you're going to remember it on the day of the test. So sine of D is going to be our opposite side, 16, over hypotenuse, 20. And so that gives us this choice right here. Awesome. And now that we know what sine of D is, we technically know what sine of I is because D and I are equivalent angles. And we want to reduce that. We get 4/5. You don't want to get the right answer and then type it in incorrectly. So as Lisa mentioned yesterday, whenever you're typing in your answer, it's not so relevant in this case because either wherever we start, we're gonna have enough space to end correctly. But in any situation where your answer is only one or two digits, you don't want to type it in the middle. Don't do that. You either need to start from the left box or end in the right box. You don't want to have your answer living in the middle of the boxes that are available. So in this case, I'm going to end on the right. My answer is 4/5. I submit it and I get my confetti. And if you want more confetti, you can get more confetti. Alrighty. So let's go ahead and do another. Sorry, let me make sure if I had another one lined up for you guys on this one. Nope. All right, so that is all the trig for this, but I am going to pause because I did say that this one had a bit more to unpack, and just check in and see if there are any other questions that didn't get a chance to get answered in the FAQ or the Q&A section.
Yeah, so we do have a question here. do the unit circle rules still apply? Like, is the sine of 90 still 1 on all triangles where that angle occurs? Yeah, so unit circle rules apply globally, right? So anytime you see like sine of 90 or like sine of 45 degrees, for example, those are all going to hold true from like what you know from the unit circle. So like the one thing is though, on the SAT, you're really unlikely to be asked to get like the sine of the actual right triangle. Usually it's going to be asking you to get the sine of like one of the other angles, sorry, of the right angle. You're going to be asked for the sine of one of the other angles. So like if you're think you're calculating sine of 90, you might want to reread the question, just make sure that's correct. But yeah, unit circles apply globally in any situation. And then we had another question. Can we do an example with the cosine x equals sine of 90 minus x? So Grace did an example a little bit earlier. We're not going to go over it again now, but when you get the recording, if you go back to like around this time, so I guess about an hour in, you should be able to find it.
Yeah. Alrighty. So our next section, and just to double check, Lisa, you're saying the guide, right? Okay, perfect. The next section that we're going to jump into is volume. And this is another one where the SAT is nice and they give us all the equations that we're going to need. And you can also see earlier where I mentioned that the special right triangles, that they give you those as well, but you're going to need to remember the 3, 4, 5 trick because that clearly is not given to you. So you have your special right triangles here. You have a reminder of the Pythagorean theorem, but we're not focused on that right now. We're focusing on volume, which is the highlighted range. So you definitely want to know when you're, hopefully you guys already know, but when you walk into when it's the test day and you walk in and you're getting started and you get to the math section, you want to know what things are going to be given to you and what things aren't. That way you're not stressing about memorizing every single equation that you've learned in your whole history of math. You want to definitely dedicate as much brain power to analyzing the questions being asked and figure out what you know and what's already given, and using that to maximize the time, to maximize how much time you have for each question. All right, so you have the different volumes. We have our different shapes: pyramid, cone, sphere, cylinder, rectangular, prism. And we are gonna do our first problem. I don't know if you guys can see the equations all that well. I may need to zoom in a little bit. Let me just do a quick zoom in temporarily. That way, double checks that I'm hiding the question, the answer, the question, the answer. All right, so I want you guys to do your best to solve this problem. Make sure you're using the correct equation. Ten more seconds. Alrighty. Okay, so let's walk through the solution for this problem. And actually, before we walk through, I'm just curious, and we kind of have the time for it. How are you guys doing on time? So if you don't know how to do this, don't worry about it. Like, don't stress about figuring it out. But if you know how to drop a reaction or an emoji in the chat, I want to kind of see how you guys are feeling about the pacing for solving these questions, given that we've been giving you 1 minute per question. and we'll just kind of see how the chat's looking, what emojis we're seeing. I don't know where my chat box is. So Lisa, what emojis are you seeing?
I'm seeing some positive emojis, which is great because you have a little bit more than a minute. So if you're able to do these like in the time that we're giving you, then you're in really good shape actually. So that's good.
Perfect. All right, that's a great check-in, and I'm glad that we're seeing some positive answers. And also remember that we're giving you guys a minute, but if you remember from the beginning, on some of the questions you have, I believe it was 87 seconds, and then the other ones, I can't remember the other section. You remember that off the top of your head, Lisa?
Yeah, so with non-calculator, you have 75 seconds. With calculator, you have about 87 seconds. Either way, like there are going to be some questions where you'll want a little bit more time. So if you're able to answer the easier ones at the beginning quickly, then that's good.
Exactly. And like, don't try to be like, oh, that was too easy. Like, let me spend more time on it. Like, if you got the answer, move on to the next question. If you want to come back and check it, put a star, but like, don't try to like psych yourself out about a question feeling like it's too easy. All right. Oh, sorry.
Really quick. If one strategy, and I think Grace, it seems like you did this when you were testing. I did this when I was testing as well. If you like are not 100% sure about a question that you answered, you can like put a little star next to the number so that you know that when you have time at the end, you can come back and review it and check it. But like your number one priority on your first pass of this test is to get through all of the questions. Because you don't want to be in the situation where like you left points on the table that like you could have gotten, but you were busy checking the ones in the beginning.
Correct. All righty. So for this question, we are working with a cone. And so we were expected to go look up, find the equation for a cone. It's right there in that first line. And then you want to make sure you're plugging in everything correctly and don't get tripped up with the double pi's, right? It's just like a function, and we're plugging in the values that we know. In this case, we are already given the volume, so we're going to replace that b with a 24 pi. Nothing fancy to it. 1/3 pi, that does not change. R squared doesn't change because that's what we're solving for. And then we can plug in our known height of 2 inches. So another thing that you want to make sure that when you're plugging in your values is that you're using all the same units. In this case, we're fine because we had cubic inches and we have inches for a cone, which is going to give us inches for our radius. And then we multiply radius squared, inches squared times inches gives us the inches cubed, or cubic inches. So just make sure that you're operating with the same units, that you're not throwing in feet and inches into the same equation, because that's not going to get you the correct answer. So when we plug in our given information and we solve the equation, we get that 6 is equal to r. And again, don't forget to make sure that the units that you're using, that you're plugging in, all align. And usually if they're having you use like a weird unit or a made up unit, they will give you that conversion factor. But I say that it's safe to at least know that 1 foot is equal to 12 inches. That's like safe bet, know that just in case. All right, so let's do a pretty cool question. I thought it was pretty cool when I was looking around at it. And we'll switch screens. And I'm gonna need to do a little zoom out action. Major zoom out action. All right, so you guys have the question and I'm gonna give you guys a minute to work through it. I'm actually gonna give you guys like a little extra time, so if you need to Google the equation, the correct equations, you can find it. right, I'm gonna give you those extra 20 seconds in case you had to look up the equations because it was kind of, you can't see it on the screen. And then we'll walk through the solution. Alrighty, so first of all, shout out to Jamal for building a bunker, and hopefully I can get the connects should anything go crazy with coronavirus. Hope you guys are staying safe out there. All right, so we are being asked to figure out the volume of the bunker in cubic feet. A quick scan of the image gives us that we are already working with feet. We don't have to worry about converting anything, so that's like a nice, something nice to see. The SAT is being nice to us. Or maybe it's just us being nice to you guys, but you want to double check that the units are like aligned with what you're solving for. All right, so let's say that we don't know what we're doing. We're like, hey, help me. All right, so looking at the bunker diagram, we have two cones and a cylinder. You can see the two cones on the ends and then the nice cylinder in the middle. And so we are gonna have to use the equation, the volume equations for cylinder and cone. We're going to use the cone one twice because we have two cones. So based on the diagram, what is the volume of the cylinder? Starting it with something nice and simple, breaking it down. So knowing that the volume of a cylinder is pi r squared times the height, had to make sure I had that right. We are looking at this one. Now, the difference between these two answer choices, one uses the radius, the other one uses the diameter. Make sure you don't get them mixed up. Often, like we know the difference between a radius and the diameter, but when you're under pressure with the SAT, it's really easy to forget and like you'll use the wrong value. So just make sure that while you're still trying to go as fast as you can, that you're being mindful of like little mistakes that might happen, and that is a common one. Make sure you're using the radius, not the diameter. Pi r squared. All right, so now that we have the volume of the cylinder, we can figure out what the volume of the cones are. So the two cones are identical. They have the same height of 5 feet, and because they're attached to the same cylinder, they also have the same base radius of 5 feet. So all we have to do is plug in our given values into the equation for a cylinder, and then just remember that we have two of those. So looking at just one of the cones, we have our equation, which is 1/3 times the height times pi times radius squared. So that's going to be 1/3 times the height, which is 5 feet, not 10, times pi times radius squared. Don't forget the squared. The SAT loves to just leave off little things here and there, subscripts that really matter, whether it's in the units or in the numbers, so be mindful of that. All right, so we have the volume of a cone, one of the cones. We have the volume of the cylinder. So all that's left is to double that volume that we got for the cylinders, and we get the correct answer. So I can scroll back up and select the correct answer. You guys see how the SAT tries to be tricky? You guys see how all these kind of look the same, but if you look closer, they're not the same. So make sure you pick the right one. I'm like double checking that I'm picking the right one, and I believe it's D, okay? So I kind of want to see if I can go back and just really highlight how similar they looked. I kind of, it's a little gray, but just be very, very careful that when, like after all that hard work you've done, that you actually pick the right answer, that you don't let them trick you because they were sneaky with where they put the pi. It's not fair, it's not fair. All right, so we are now going to move into our next section, and that is going to be, I want to make sure that I remember correctly which one I wanted to do next. It's a lot to remember all at once. We are going to move into, I believe it's circles. I feel like I'm missing something. We're going to do circles next. All right. Let's find where it is on my screen. There we go.
finding the page, one quick thing I wanted to just mention, because she's kind of touched on this, is that if you don't find an exact match to your answer in the answer choices, that means your answer is wrong. Don't look for one that like kind of looks kind of similar, because chances are that's actually the SAT trying to trick you, and that like they know that path of like, they know the path that you've taken to get to maybe like a somewhat wrong answer, and they've put an answer that looks kind of like that as a choice. Go back and check your work. Like, don't, I see this happen a lot where students are like, okay, I got my answer. There's not one that looks exactly like it, but choice C like kind of looks like it, so I'm gonna pick it. That's not a good strategy. And like, you've already done so much of the work, most likely you just made like a small mistake somewhere. And as like a general strategy, like if while you're doing your practice tests, write down the types of careless or like mistakes that you're making as you're taking the test. And then like before test day, like the night before the test, don't do too much studying, but just like go over that list of like errors that you commonly make and just like drill in your brain, like, I am not going to mess up my units, or like, I am not going to like use the wrong equation for a cylinder versus a cone, or whatever it is that you're messing up. Like, that's what you should review the night before, your careless errors, because those are points that are yours, so you should take them. Okay, back to Grace.
Doing that, like underline, exclamation point, bold, italicize, all of that. Get your points. All right, so I lied. We're going to do probability next. We're going to say circles for last because circles, Post Malone, anyone? No? Okay, maybe. Okay, so probability. Given a chart, so in the probability section, you're going to be given a chart, most likely is what we've seen. And then using that chart of possible events, you're going to be asked to calculate the probability of something specifically happening. And so when it comes to probability, if you Google like, hey, what do I need to know about probability on the SAT? You're going to see a bunch of stuff. You're going to see words like conditional probability. You're going to see words like unions or whatever. But really, the main thing you need to know for probability that we have seen, right? I don't want to like misguide you guys, but like based on the questions that we've seen, the most common type of question you're going to see involving probability is just looking at a chart and determining what the probability of something happening based on what is provided. And the main one that, the only like specific one that I will highlight today is conditional probability, where it's a probability of something happening given that something already has taken place. And that one is pretty simple. And then if there is time at the end and there's people who are curious about more about probabilities, then I can share a little bit more about that. All right, so looking at this table, we're given some data. Oops, sorry.
We're still on the almost fun page.
Oh, I'm sorry, I jumped ahead. I forgot to unpause my share. Thank you, Lisa, so I have you. All right. There we go. Wow. So I was just talking and y'all were definitely not seeing what I was seeing. That's okay. All right. So that being said, I'm going to let you guys read this question and then do your best to solve this problem. See what you already know. Alrighty. So the question itself isn't too difficult, but what you do want to make sure that you know is like what numbers to use, right? There's so much data, there's so many numbers. like what am I using to find this probability? So looking at this question, the second part of it, where it says, based on the data in the table, what is the probability that a gas station customer selected at random on that day did not purchase gasoline? So the easiest thing to determine is, what is the event that I'm finding the probability of? And in this case, the event is the person that did not purchase gasoline. So that's our first number that we're going to look for, is total customers that did not purchase gasoline. And they're wanting us to find the probability out of all of the customers that day, which in this case is 135. So again, notice that we had all of these other numbers, but we only had to pull out 2 from this data. And that's what I would say is like the trickier part of probability, is just making sure that you are using the right numbers from the data that you're provided with. So as long as you're able to pinpoint those values, you should be good to go when it comes to probability. Alrighty, so let's go ahead and do a probability question. Different screen. Perfect. All right, this one's has a little bit more of a twist to it, but I want to see if you guys can figure it out. All right, you share. Screen 2, share. Alrighty. Got a little Avenger action. I'll give you guys a minute, maybe a little bit extra, but let's start with a minute. Alrighty. So looking at this problem, you can probably, maybe, hopefully get to the correct answer if we fully understand the Avengers, or like how to do probabilities, not the Avengers. We don't need to know about the Avengers. We got to know how to do probability. RIP to Iron Man and Black Panther. Oh goodness, it's been a year. All right, so we are, first things first, don't get tripped up by the number 7 in Avenger 7. It definitely it took me a couple of reads the first time I looked at this problem, but don't get tripped up by that. Sometimes if you're rushing, every number might seem important, but you gotta read carefully because some might not be. The 7 does not matter. So we know that there are 5 times as many blank tickets as there are actual Avengers tickets. If we let X be the number of Avengers tickets, how many blank tickets are there? So this is the part where it's a little bit of a twist before we can get to our final answer. Like, we're not given a table, but we are still being asked to really critically think about this problem and figure out what is the total possible events, which is the total number of tickets. And then what we're looking for is the correct ticket being selected by our dear friend, I forgot her name, who is it? Ruby. All right, so if we know that there are 5 times as many blank tickets as the actual Avengers tickets, then the equation or the expression that is going to symbolize that is 5x. Okay, it's a multiple. We're not adding 5. It's like for every 1 good ticket, there's 5 blank lousy tickets. All right, so that means that there are X plus 5X total tickets. Don't get confused. I know we just said that it's 5X, but now we're seeing this like X plus 5X thing. So that means that we have the good ticket, and then we have the additional tickets that aren't as good. So in total, we have 6x tickets. So I'm gonna like pause there to let that marinate a little bit, because we just said it was 5x, but then we're seeing something else. All right, so one more time is in the previous follow-up question, we were saying that for every good ticket, there is 5 times as many bad tickets. And then on this follow-up question, we're now using that proportion to figure out how many total tickets there are. So if there's one good ticket, then that means that there are 5 times as many bad tickets or blank tickets. So one good ticket plus 5 bad tickets. We have 6 X tickets, where X represents the total tickets, or not the total tickets, but like total good tickets. All right. Sorry, that was a lot of tickets and X's, but hopefully that makes sense. And I'm now going to press 6X, so we can keep going. All righty, so we're hoping to get the number, or the probability that we're solving for is the probability of her selecting the Avengers tickets out of all the total tickets that there are. And so given the relation that we know, we have X representing the Avenger ticket divided by 6X, and the X's cancel out. Dividing the same thing by the same thing gives you 1 always, whether it's a million by a million, you're still getting 1. And so given that, we get 1/6. Scrolling back up, A was our correct answer. Okay. Alrighty. And now, as promised, we're going to do circle. And I think we're going to end just in time, but I'll try to go through this one a little bit quickly so that if there's any questions out there that haven't gotten answered, we can give you guys some of those responses. And look, circles is right here. I just have to scroll back to this screen. Perfect. Alrighty, so with circles, the key thing, the equation is there. That's okay. We got to save time for this one anyways. All right, so with circles, the key thing to remember is how to understand the equation of a circle. And you're gonna want to remember, so we're just gonna like walk through this problem and then I'll like explain the main concepts as I walk through the problem. So we're given a circle that has a center that's at 0.57 and its radius is 2, meaning it's 2 units. And we want to figure out which of the following represents the equation of the circle. So the first thing to remember, if you guys look at this little text below the question, is that whenever you're turning it into an equation, you are going to negate, meaning make the values of the center point, not negative, but you're going to change their sign, right? Because if it's already negative, it's not going to become positive. If it's positive, it's going to become negative. So in this case, we are looking for an equation that has x minus 5 and x minus 7, okay? So we can automatically rule out B and D. And the last thing you're going to do is on the other side of the equation, you are going to square the radius. So we know that the radius is 2. 2 squared is 4. And so our final equation looks like what's on the bottom. And in this case, that matches, make sure you pick the right one after doing all that work. That matches answer choice A. Okay. So again, you negate the center values. That doesn't mean that they're becoming negative. You're just changing their sign. You're flipping the sign when you plug it into the equation below, and then you are squaring the radius. So you're going to be expected to know how to identify the correct equation for a circle given the center points and the radius. You're also going to be you're going to be expected to know how to determine the center point and the radius given an equation for a circle. So it works both ways, and you want to make sure that you are comfortable doing both. So that being said, let's do our last question, and then we'll quickly walk through the solution and take some questions that you guys have. All right, let's talk about pizza. I'll give you guys a minute. All right. So for this question, just to honor our time, I am just going to quickly talk through it and go ahead and give you guys the answer. And if you clicked A, or if you selected A, you were close, but you missed a small detail that's actually pretty big. And the correct answer should actually be C. So let's go back and talk about it. So this is where you want to definitely, like earlier I mentioned, be very, very careful that you are answering what the SAT question wants you to answer. So they're asking, what is the radius of the large pizza? So Jess's pizza. So not the typical personal pizza, pan pizza. So if we're looking at the equation for a typical pizza, not a Jess-sized pizza, and we're only focusing on the radius, we can actually like disregard the left side and just see what's happening on the right side, given that it's already in circle equation form. So if we're talking about a typical personal pizza, then the radius would have been the square root of 14, because you know that here we square what the radius is. So that means that the 14 is the radius squared. Working backwards, we get square root of 14. That will be all nice and dandy if we wanted to know the radius of a typical pizza, but the SAT wants to know the radius of a large size pizza, aka a just size pizza. So we have to multiply that value by 3. You're going to see questions like that a lot. So again, make sure that what you have at the end matches what the SAT was asking you to solve for in the beginning. Because you definitely don't want, you don't want to get a question wrong that you would have known how to do. It was just like a small wording or a small thing that you missed that caused you to get it wrong. So that's where Lisa, her point about like reviewing what mistakes you made, like small mistakes you made, and like practicing those over and over again until so you can get like the best score possible. All right, there's 2 minutes left, but I'm all done with going through the concepts. Thank you so much for hearing me out, and I hope that you guys find that helpful. And I'm sure that you guys have more questions. You want to do more practice. I really want to encourage you guys to check out the Almost Fun website. We have a library that we're constantly building up with SAT questions, math, writing, reading, and then we also have smaller lessons and guides that you might find helpful. So check it out. It's a great place to start, and then you can build up from there.
So I think we actually, someone noticed that we missed imaginary numbers. So can you do a quick, like using the guide, go through imaginary numbers? And while you're getting set up, I'm going to try to answer 2 of the questions here.
Yeah.
So that way we can save time. We have a question here. What is at stake with a bad SAT score? What is the SAT even used for by colleges? And the second question is kind of similar. Does GPA matter more than SAT scores, or does volunteering matter more than SAT scores and GPA? So basically, colleges are trying to get an idea of 2 different things. They're trying to get an idea of like how prepared you are for a college course, so kind of like where your intellect is at. And then they're also trying to get an idea of like who you are as a person. What are you interested in? What have you committed time to? Like, what are you passionate about? So your GPA and your SAT score help them figure out like this, like your intellect side of things. They're both pieces that fill in that puzzle of who you are as a student. And for schools where the SAT is optional, if you have a really great GPA and not a great SAT score, it's probably fine to just like let them focus on that really strong GPA, right? You want to paint a picture of yourself as a solid student. GPA and SAT are 2 things that go into that. The other side of it is like who you are as a person, not as a student. So like volunteering plays a role in that. Your extracurriculars play a role, and like that, those 2 things, neither one is more important than the other. I mean, maybe for some schools there might be like one that's weighed a little bit more heavily, but as far as I know from like the consultants we talk to and the colleges that we work with, those 2 pieces are both equally important. And so you want to be a strong candidate on both sides. Okay, I'll let Grace do a quick imaginary number review, and then we'll go through the last couple of questions.
Awesome. Oh wait, can you, yeah, my volume is still on. All right, and I want to make sure that I resume share. All right, so with the imaginary numbers, you might get 1 or 2 imaginary number problems on the test, so like don't sweat too hard if, oh, is my volume?
No, you're on the My Drive instead.
Ah, darn it, I thought I had it. All right, let's go here. Now we're good. Imaginary numbers.
Yeah.
Yay. Not an imaginary screen, imaginary numbers. All right. So you might get 1 or 2 imaginary number problems on the test. And so it's helpful to know what they are and how they operate. That way you can get those points from those 1 or 2 questions. Imaginary numbers are numbers that are a normal number multiplied by the square root of -1. Square root of -1 sounds weird, and so we use the I to represent that square root, right? We're not used to taking square roots of negative numbers, but leave it to mathematicians to figure out a way to make it happen. Because we can't really take the square root of a negative number, as I was just saying, we call these imaginary numbers, but we still have to use them. The cool thing about the square root of -1 is that it cycles up as you power it up. So if you look at this table, you can see that the square root of -1 is I, our imaginary number. If you square it, you get -1. If you cube it, you get the negative of the square root of -1. And if you quadruple it, I'm not sure, you get 1. And the best way to look at it is kind of looking at I squared times I squared, -1 times -1, you get that 1. And then after that, as it mentions in the line right underneath, it cycles through, right? So as long as you have those first 4 power ups remembered, then that cycle continues over and over again. So you don't have to memorize a gazillion different numbers. All right, so here's an example from the test where we're asked which of the following is equal to the complex number shown above. You have I times 7 minus 3I. All right, so this is going to involve a little distribution because if you're looking at the answer choices, we don't see any parentheses. So we know that we're going to have to do some distribution. So in the first step, we're going to distribute the I. So we're going to be left with 7I minus 3I squared. The I has to go to both of them. All right, so that takes us to here where we have 7I minus 3I squared. We have to remember that I squared is really equal to -1. So we have 7I minus 3 times -1. We replace the I squared with a -1 because remember, if the square root of -1 is I, then I squared is equal to -1, vice versa. And then that gives us the final answer of 7I plus 3 because when you subtract a negative, it becomes positive. So when you're working with imaginary numbers, you can still distribute them and multiply it as you normally would. You're going to treat it like a variable, but that variable has a value. It's a funky value, but that value matters even if we call it imaginary. We can't imagine it away. Okay, hopefully that helps you guys.
Awesome. Thank you, Grace. Okay, we're going to go through questions now. I know we're like pretty over time, but Grace and I will stick around and answer some of these questions, so they'll be on the recording, and when you get it in your email, you'll be able to access them. So I'm going to go according to like the ones that are more math focused and then the ones that are more just general focused. So the first one that we'll go through is how would you find what something with a bigger exponent is, like I to the 89. So the trick here is very much related to the cycle that Grace was talking about, where like it starts with I and then it's I squared, which is -1, and then I cubed, which is -I, and then I to the 4th, which is 1, and then it cycles. So the key is to find the remainder. So I to the 89 divided by 4, the remainder is 1. And so that's going to be equal to I to the 1. So you're going to take whatever exponent it is, divide it by 4, get the remainder, and then match that up. And then that's going to be your new exponent. And that's what you're going to use instead. So hopefully that was helpful for answering that one. Next, can you go over compound and simple interest if we have spare time? Yes, we'll go through this really quickly. Okay. So compound interest, okay, let's say that you start with $100 in your account. Compound interest means that like any interest year over year is taken off of that initial $100. So like, let's say that you get 3% annual interest. The first year that 3% will be off of the 100, so you'll get $3. The second year that 3% will still be off of the $100, so you'll get another $3. So the way that you would calculate your total interest over like n years would be the amount you put in times the interest rate times n. The way that compound interest works is that each year the interest is off of your new amount. So the first year, the interest of 3% would be $3 because it's off of the $100. But your second year, the interest is off of $103. And so it's 3% of that, which I cannot do in my head, but would be slightly bigger. So the way that you would do it after n years would be your amount times the interest rate to the power of the number of years, because you're compounding it every single year. Hopefully that was helpful and that made sense. Okay, powering through these. Next couple are more about like general advice. So I'll start from the one that was asked first. What are some extracurriculars that we did? Just curious. I can go first and then Grace can share. I did a lot of like general clubs. So I did Science Olympiad, I did student government, and I did like piano and ballet and stuff. I almost feel like if I were a candidate today for college, I would try to focus on like one or two things that I was really excited about and do those as much as possible. In my essay, I did write specifically about my love for ballet and like how that related to my love for math, and like tried to present myself as this like, I don't know, multi-passioned individual. It's a super cheesy essay. I hate to read it now, but like, I think that the most important thing is to do things that you're excited about. So don't do things that like we did because we got into Harvard. Do things that you are excited about, because that way when you write about it, when you talk to people about it, it'll come through. Like they'll be able to see your passion. Like the people that we admire, the people that people everywhere admire are the ones who are doing the things that they love and can like talk really well about them. Like this is a super random example, but like, you know, there's like videos that Vogue does on YouTube that are like people answering questions or talking about like their jobs. And some of the most interesting ones are not ones you would expect, but it's just because somebody is so passionate about what they do that like other people flock to that. And colleges are the same way. That was a long thing, but Gracie should say what you.
No, I definitely agree. And like, so for me, like the extracurriculars that I did were pretty kind of traditional. I mean, when I look back, I'm like, what did I do in high school? I did like international club. I dabbled with chess club. Definitely, like if I were to challenge one of you guys, y'all would definitely beat me. And I try to like do like we didn't have like a dance team, but like anytime there was like a talent show or like some sort of showcase, I like definitely signed up for that because I love dancing. And then the other thing that I did was mathletes. It was an experience. It definitely was not at like, I don't know. It was an experience. Like people were really intense and I was not ready for that life. But what I was really passionate about was education, which is why I'm working at Almost Fun. I actually spent the last 4 years teaching, which like when you're going to Harvard, it's definitely not the traditional path. Like, especially, I don't know if anyone else can relate, if you're like an immigrant child and like your parents were like, this is the golden ticket. It was definitely not the traditional path, but I knew like what I was passionate about. And so all throughout my my upbringing, like junior high school, I would volunteer a lot at my church with teaching and like helping out with like the different ministries. So I think that's where like my passion continued to shine on. And even with the peer pressure, like, I don't know, the feeling that I needed to do something more traditional, like I stuck true to like what I felt passionate about and where I felt like I could really make a difference.
Cool. The next question is, any essay advice? What are some things admissions counselors see too often? So for this, I'm actually going to pull up some of our guides really quick because we have a couple guides focused on personal statement. So first off, we have like a general guide here that walks through like the whole process of brainstorming a story, trying to create something unique for your admissions officers to read through. And then we go through some ways of like structuring your story. And this is based on like story circles. So this is like this woman at Disney who like writes scripts. She actually, we were able to meet with her and she talked a little bit about like her way of thinking about stories and how they come up with the stories for movies like Moana and Brave. And like, it actually ends up being really similar to how you want to think about your personal statement, because it is this story of growth for you, right? It's a story where you're sharing a situation or a challenge that helped you grow as a person and what you learned and how you're like so much better of an individual now and a perfect candidate for their college. And so like if you follow this structure, it'll really help you craft your story in a strong way. And it's less about like specifically what you're talking about and more how you tell that story. Like even the most cliche topic or like cliche story, if you tell it in a really strong way, it becomes an amazing essay. We have a couple guides on like things to avoid, and I think this gets to the part of the question about like what do admissions counselors see too much of. We've listed out things that we see a lot of in essays that don't make them good, and things that we've also heard from admissions officers are not great. Like we see students who try to kind of gain sympathy by talking about all of the bad things that have happened in their lives. And like your essay, you want your essay to be hopeful, right? Like you want to be focused more on how you overcame something versus like what it was that you overcame. And so listing out a bunch of complaints is not going to do you any favors. The other thing is like if you're writing about someone else, like don't make them the hero of your story. You are the hero of your story. So make sure that like you are the person that we are excited about and that we want to learn more about and read more about. The other thing is that there's often essays that like read too much like a resume, like you're just saying all of the different things that you did versus like telling a story about yourself, right? And that's really what we want to do here, because it's something that they're not getting from any other part of your application. One more thing, lack of focus. If you use our structure that I just talked about, this will help you focus your essay and tighten it up. But like we want to make sure that the essays and stories we tell are really, really focused, and there's not like too many extra details that like draw our attention away and make us confused. Like it's as much about the story as how you tell it, and you're showcasing your writing skill, basically. Make sure you include the personal growth. Like don't gloss over it. Be vulnerable, be yourself, share what it was about something that like really forced you to grow and how that happened. That's interesting. The colleges want to know how you deal with challenge, because college will be challenging for most students, and they want to know that you can handle it. Don't use overcomplicated language. This is like one of my pet peeves when I read essays, but like I've actually seen this in an essay, and the student gave me permission to use this, but I was already being informed about the divergent underlying notions encompassing gender. And I'm like, no, just be clear. Clear about what you want to say, right? Like you rely on the power of your story versus like trying to use fancy words to sound maybe like really smart, because actually what you just want to do is be clear. And then check your grammar and spelling. That's also a pet peeve of mine. But yeah, make sure that you use like Grammarly or something. There's so many spell checkers that you should be able to find something that's helpful. Okay, let me keep going here. What SAT score do you need for an Ivy League? So not just for an Ivy League, but any college will on their website have a page that tells you like the average score of their student body this year. You can use that as like a benchmark of where you want to be. I think that like for a lot of the Ivies, you want to be in like at least 1,200, ideally above 1,400. They're really looking for higher level scores there. And if you don't have a high score, then like you just want to make sure you shine in another part of your application, right? Like maybe you have like a hobby that you do that you're really excited about, and that's maybe why like you don't have a really strong SAT score. Then focus on talking about that hobby in your personal statement and like why it's really exciting for you and why you care so much about it. Will the SAT be online this year, or is it still in person? As of right now, it's still in person. The College Board has kind of like said that they will have an online version if like too many testing sites get closed, but like as far as we know, they are not doing that yet, and so everything is still in person right now. I'm gonna go back to the beginning. I have test taking anxiety, and I've noticed I freeze while taking tests and practicing, so I get careless. Any tips? Yeah, I mean, this is tough. Like this was also kind of for me, like I actually just tend to get really nervous energy, like, and then like I go through the questions too quickly and I make careless errors. You really just have to practice, and like this is actually why they recommend taking the test twice, because the second time you take it, like you'll be a little bit more comfortable in that environment. I also just think that like the biggest thing that makes students stressed out usually is the timing. you get stressed out because you're like, am I spending too much time on this? Am I like not going to be able to finish? And that's why like if you practice timing yourself, and we're actually going to talk about this tomorrow on the reading and writing section, how to be cautious of time for those two sections. But if you practice timing yourself and you like build your confidence in like your ability to finish this test in the time that you have on test day, like you'll feel a little bit more comfortable because you'll know that you can do it. Like part of anxiety, I think, comes from not knowing or like the unknown or like being unsure. And so the more you can build up your confidence in this test, the better. Okay. I'm concerned because I am only able to take one SAT before I apply to colleges. Any advice? That's okay. Just make sure that you take practice tests then. Like put yourself in that situation as similarly as possible. Like set aside I think it's like 3 hours and 45 minutes on a weekend day, like at the time that you would take it. So if it's like 9 or 10 a.m., whatever the time is, and like sit in a quiet place in your house if you can find one and do the test exactly as you would do it on test day. That like just try to simulate taking it twice. You know, it's all about like the behavioral psychology of it, like getting used to that environment, getting used to like this experience. Don't stress out about it. Just try and prepare as much as you can. And like I said, do that practice.
And also, I mean, Lisa, correct me if has changed, but I do believe that some deadlines for like the testing scores are often after like the application deadline. So like just double check like when your college or university that you're applying to needs your scores by, because you might still have a chance to like take a second one. I know that was the case for me when I didn't realize that Harvard required subject tests, so I had to quickly do that. So definitely check like what the deadline for each submission is. There's an application deadline, and then there's like a test scores deadline.
Yeah, that's definitely true. So just check with the school, because every school has like their own way of doing things because they like to make our lives hard. Okay, can I get into, oh, I see a lot of these on Reddit actually. Can you get into an Ivy League if you have a 3.75 GPA in high school, a 1300 GPA, and some extracurriculars? Okay, so every student is different. And so if you are posting this question anywhere else and anyone is giving you a definitive answer, you should ignore it, because every student is different and your application is going to be so much of who you are that like you might have the exact same stats as someone else, but like based on who you are as a student, as a person, like your likelihood of getting into the school might be different. So I would say like apply to all the schools that you really want to go to, and then just like trust that, you know, you are a great student, you will get into a great school, whether it's Ivy or not. Like you're going to have a great experience. And if the school passes on you, like that's their loss, right? They lost out on an amazing student. Don't feel bad about that. You, regardless of what they do, are going to have a great experience in college. What prep books would you recommend for the SAT? So I mostly recommend doing the practice tests on the College Board, and then doing practice questions with us and then with Khan Academy. The prep books themselves, like I think that they range in how close they are actually going to be to the SAT. We know that our questions are pretty far from what the SAT looks like, but our goal is to help you master these skills and then allow you to like really focus on using like the practice tests to like drill the problems and like get those, just like master and be comfortable with them. But like Princeton Review, I think skews a little bit harder. Kaplan, I think skews a little bit easier. And so like it kind of, I think the closest thing that you're going to get is doing the practice test from the College Board to get an idea of what's going to be on the test. Okay, where do I sign up for reading and writing? So you can sign up on the Fiveable site. They have like a little banner, I think still at the bottom, where you can sign up, and also on courses.fiveable, where there's like an SAT section at the top. You can click on that and sign up for that session. We are not going to talk about the essay in that session. We're really going to be focused on strategies for reading and writing, specifically the different types of passages, how to manage your time, how to make sure that like you don't run out of time. Those are the key things we're going to be focusing on. Okay. So a personal statement should be told informally, like a narrative, since it's not like a resume. What's the line between inappropriate, informal, and too formal? That's a good question. You don't want to talk, it's not like you're writing like a tweet or an Instagram caption. Like you still want to write it with like proper grammar, proper punctuation. You don't want to use like slang in it. You want to use like formal English language, but like you do want to be telling a story. And so you don't want it to be so like it's almost like you're talking to someone, like you're telling them your story, except that you're being like really careful about grammar and punctuation. I think that the best advice that I can give here is like to write one version of it that's like a little bit more informal, and then go in and like tighten it up in certain places. Like I think that being informal in small pieces, like as like a little bit of a surprise, I actually quite like. And I know a lot of counselors like it too, because like it's a little bit of a break, you know, like you don't want your whole personal statement to be informal, but like small snippets of like your personality are really nice. And so I kind of recommend either like starting super formal and like throwing things in, or starting a little bit more informal and like tightening up sections, either way. Any tips for starting a nonprofit? I heard that this is a great extracurricular to put on your resume for college applications. It definitely is, because it shows your commitment to community, but I think it also can be kind of clear if you only did it for your resume, because like there won't be as much to, like, I think that if you really care about an issue and you want to start a nonprofit, and also it'll look great on your resume, you will have incentive and time to like really put a lot of work into that. Nonprofits really are most impressive when like they're able to have impact. So like I know folks from Harvard who started nonprofits in high school, where like they were mentoring other students, they developed programming, like they could say on the resume, we supported like X number of students every year. We helped like X number of students do this, or like we helped the community in this way. Being able to show that impact that you're having is much more impressive than just like saying I started a nonprofit, because like actually having done it, it's pretty easy to like file the paperwork and start a nonprofit. The hard part is having impact. And colleges are smart. They'll be able to tell if you're like just doing it to have a line on your resume, or if you're doing it because you really care about an issue.
The question a lot of them are wondering is, what did we major in?
Okay. I majored in math and computer science.
I did mechanical engineering.
We are running Almost Fun together now. We are focused on creating educational content that is inspiring and engaging and helps you like learning instead of making it feel like a burden. Okay, let's see. I want to go to the medical field, and I'm a sports trainer in my school. Would it be really good to focus my essay on that? Yeah, I think that's a really interesting story that you could tell. I think that you could do something with like telling a bit of a personal story about why you decided to be a sports trainer. Specifically rehab, I think is like really compelling, because you can talk about, you know, the different experiences, the cycle that you see of like helping someone get back into shape and becoming healthy again. Like I think that there's a really nice transition there of like what you're doing now and why, and how that like develops into what you want to do in the future. Those are always really powerful, right? Because it shows like you have an idea of what you want to do based on all this work that you've been doing right now. So I think that's a great idea for an essay. The personal statement is different from the other required essays, right? Yeah, usually. So I think some schools will do like a personal statement, and then they'll have like a separate one for why you want to go to this school specifically. I think just be really careful about the prompt. That's the other piece of advice that I usually give, is like check the prompt, read it really carefully. Some are like super open-ended. I think Stanford's, when we were applying, I don't know if it's still this way, was like what matters to you and why. Like it's so broad and general. Some schools, like I know NYU's is a little bit more structured, and it's like specifically like why do you want to come to NYU? At least it was a couple of years ago. So check the prompts. Be really careful about what those are asking you for. But generally, especially the Ivies, like the personal statement prompt is very much like focused on who you are as a person, not necessarily like what it is you want to get out of the school, although it's nice to include that towards the end of your essay. All right, we're gonna do these 3 questions and then that's it. Do colleges require sports in high school? If you do not play a sport, will you be ejected from an Ivy League? No, you don't have to do a sport. I am not athletic at all, and I was able to go to an Ivy League. Again, like they don't have concrete requirements on what extracurriculars that you do. It's more just like you need to show that you have some passions and commitments outside of school, that you are a person outside of being a student. But you will not be rejected for not playing a sport. You might have a better chance of getting in if you're like a varsity athlete, but that's a whole different thing. How many schools do we recommend applying to? I think like in general, the recommendation is like 2 to 3 reach schools, 2 to 3 schools that like you feel pretty good about getting into. And then like 2 to 3 safety schools as well. Like safety and feel pretty good about getting into, like there's a fine line between that. But like I think generally like 6 to 7 schools is a good balance, especially because it'll help give you like a wide range of options as well. And you can really focus on like the school that you really want to attend to. But talk to your counselor. Your counselor is supposed to be your partner in doing this. Like they should be able to help you figure out what schools you want to go to and narrow down your list of the ones you want to apply to in the end. Okay, last one. Does simply playing a sport count as an extracurricular, or do you need a leadership position for it to count? No, you don't need a leadership position. Just playing counts, like being a player on a team. It shows like you know how to work well with others. You're a team player. I think like I don't know if the Common App still does this, but like sometimes they ask for you to talk a little bit about your extracurriculars. That might be an opportunity to like talk about just like why you were involved with that sport. I have actually read a truly excellent essay about someone who was part of a team but like never took on a leadership position and why, and like how he ended up actually taking on like a not formal leadership position, but like a leadership position within the team where it was like supporting everyone emotionally, making sure that like everyone felt good and excited, helping like the younger students like feel comfortable. And he wasn't formally captain, but he was like this like non-titled captain. I can't remember the words he used, but it was such a powerful essay because it showed how he was able to lead a team without having like an official position, which is a lot harder actually to lead someone without having formal authority. So there's a lot of different ways that you can structure an essay and your extracurriculars. Okay, cool. That is all the questions.
So sorry, I meant to like type an answer to a question, but I accidentally like dismissed it or something. Someone asked if they can take an AP class without taking the class in high school. The answer is yes, but you'll definitely have to study extra hard for it, or like make sure you're prepared for it, and then double check with your counselor about make sure you're registering for it correctly and in time.
Okay, cool. Thank you, everyone. We will be back tomorrow night with another stream. That will be our last one, but we are having a lot of fun with you guys, and we hope that this has been helpful. So we will see you tomorrow.